Hi, welcome to Map Demo 2 in L221. Here's the map. I'll be working through the solution with you today. And the blank map, just like this, is posted on OnQ, so you can download it and complete it yourself. So in this scenario, we have 3 map units, units A, B, and C. One of our objectives is to determine the age relationships and fill in the map units. We have quite a few outcrops and some contacts between some units. We have strike and dip values of bedding and strike and dip of cleavage. We can see, just having an overview look at the map, we have bedding measurements that change direction, and so we're already thinking we're in folded terrain. We have bedding measurements way up here in the blank unit and all the way across. As I mentioned, I like to start on one side of the map and work my way across. So if we start off on this west side, we have a nice well-constrained outcrop. We see all 3 map units within it as observed contacts, and we have a bedding measurement in that outcrop. So if we start here on this left outcrop and extend the contact outside toward the west, we have fairly good control information, so our contact will be dashed close to the outcrop as we follow this orientation of bedding, and as we get further away that will change to a dotted contact. As we move to the other side of the contact, again we start off, it's reasonable to put a dashed contact, and somehow we need to figure out how these meet. And so the simplest way to do that is to make a fold. We have an idea of the thickness of this unit on plan view. Again, depending on the dip of the structure, this is an apparent thickness, but the dip doesn't change too much between these 2 outcrops, so it's fairly straightforward to approximate that. And now as we go to look at the hinge, we want to have a look at our cleavage. So our cleavage is oriented this way, so all of the axial planes for the folds will be parallel to cleavage. So if we take a bit of a interpretation like this, we fortunately have this outcrop which constrains how far the black unit can go. So we have very good control and constraint on that fold interpretation. Okay, that looks pretty good. As we move to the next section of the map, we have these 2 outcrops that we have to connect next. Something like that. As you're sketching in your contacts, I encourage you to do this in pencil first, so it's easy to erase the trials as you go. If you want to slightly change your model. And at this point, I'm maintaining the appropriate thickness of the black unit. And we have a hinge here of the folds. We also have this bedding measurement that might loosely apply to near the hinge of the fold down here if we follow it down looking at cleavage. And already we're looking ahead to the next outcrop and measurements that's applying, so we can start to maybe work it backwards a bit. And again, maintaining the same unit thickness as we go up. As we get closer to that outcrop with the data, we can change our contact type to dashed lines to reflect our higher confidence of our interpretation. All right, now looking ahead, we have a bedding measurement the strike line of the bedding measurement is nearly perpendicular to the strike line of cleavage. So this is a lucky bedding measurement in a hinge zone. So we know that we're going to have another fold over here. And our marker unit, we have to fold it around somehow and intersect with this outcrop that fully contains that unit. So again, we'll try to put in a fold hinge. We're trying to maintain, again, this sort of dominant structural trend defined by cleavage. So now we have this other outcrop with a contact, so we can't continue our interpretation. We're forced to make another fold. And in the context of the scale of the map, you could consider what we're about to do a minor fold. We have another outcrop up here that's interfering with our extension going straight, so we have to again turn the contact in another fold to avoid this outcrop. So if we cut it pretty close, we do have enough room to fit another fold. Thinking ahead again, we have this bedding measurement fairly perpendicular to cleavage, so this is already indicating another fold hinge. And we have the outcrop data showing the blank unit with a gap and then the dotted unit over here. So we know, based on our previous interpretations and even our observation in the outcrop in the far west side of the map, the black unit has to somehow go in between these two units. So we'll put in another fold. As we move across, we have this new bedding measurement to help direct the orientation of our limb. There we go. So that's our effectively complete an interpretation. We can shade in our units in the map. And for a good copy, I would certainly be inking in the contacts so they stand out a bit better, but I won't take the time to do that in this video. Instead of having a speckled unit, which will get a bit confusing with all the dots we're using for the contacts, I'm going to transform the speckled unit into a blue unit. So I'll color in all of the outcrops in a darker shade of blue. And once that's done, I'll shade in the rest of the map area with the same light blue color. And remember, when we're coloring in outside of the outcrops, make sure you use a lighter shade. And to help your map coloring look good, you want to make sure you're trying to color at the same orientation and the same weight to try to make it all blend together. There we go. So the next step is we can have a look at figuring out which unit is A, B, and C. If we look at our folds, the first thing we should identify is if these are anticlines or synclines. If we have a look at the fold on the west, we have the two limbs dipping like this. So if you put it together into this sort of bowl shape, this is a syncline that's plunging toward the south. So we can draw our axial trace parallel to cleavage. It's plunging that way, so we put an arrow on this side. And to indicate that it's a syncline, we have our syncline symbol with the two arrows pointing together. Our next fold, we also have a fold axis, and because all of the rocks were deformed together, they're all going to be plunging the same direction. But in this case, we have the bedding measurements on the limbs dipping like this, which is an anticline, that arch shape. And it makes very good sense as well to check that we have a syncline right beside an anticline. As we continue to our next fold hinge, we have fold axis to add on, plunging in that direction, and again we're back to, with this bedding measurement here, a syncline. We have 1, 2, 3 more hinges, an anticline, syncline, and an anticline to finish. And this anticline also makes sense. We've had that bedding measurement dipping out on the limb, and we also have this bedding measurement going down, which defines that fold closure of the anticline. Now that we've sorted that out, this bedding measurement is most close to the fold hinge, dipping at 34 degrees. So from that, we can interpret that all of our fold axes are plunging at 34 degrees as well. With the syncline, the youngest rocks are in the core and the oldest rocks are underneath. And an anticline, in the arch, we have the oldest rocks on top or outside of the closure and the oldest rocks in the core. So our unit A becomes the blank unit, which is oldest. Unit B becomes our black unit. And unit C becomes our speckled blue unit as the youngest. Excellent, so we have completed our map, and the next step is to do the cross-section. So where, in this case, is a good place for a cross-section? As always, we want to be close to the dense amount of data we can, and we want it to be perpendicular to the structural trend, so perpendicular to cleavage and all of the axial traces. To be close to or central to all of the data is probably somewhere around there. We have bedding measurements very close to the cross-section line, and we've also got fairly close to the bedding measurements on the northern half of the map. So now we can take our ruler and draw our cross-section line. We go from A on the left to A prime on the right. The next step is to transfer our map data onto a cross-section on another piece of paper. So we have a scrap piece of paper here that we line up with our cross-section and use the edge to mark out our important features of our cross-section that intersect. So we have our contacts here, and when I mark on the contacts, I usually give a clue about which colors of each unit are right at that line, just so it helps me remember where along the cross-section line I am. Okay, and so now we want to add on our measurements. We have bedding 1's 61 degrees. If we can sort of see through our paper where the center of that is and mark it up on the cross-section line. We have the next bedding 46, so again try to look at this, find the center of it through the paper you're tracing on. We have this 40-degree bedding. this 60 degree, and again transfer it parallel to the cleavage straight down to that cross-section line. Okay, do we have any others? Quick check. All right, so there we go. And now we can move our map and go to our blank piece of paper on which we will draw our cross-section. Now that we have our cross-section, put a little dot to transfer all of those contacts and measurement locations onto the line on the cross-section paper. And again, you can fill in a little bit the color where you have the different map units intersecting the ground surface. For all of our bedding measurements, remember we have to calculate the apparent dips. So if we take look at our map units again for a second, to find out the orientation of our bedding measurements, we use our Douglas protractor and orient north of the Douglas protractor to north on the map and center the Douglas protractor on the measurement location. Once we've done that, we can hold the straight edge or the edge of a piece of paper along the strike line of the measurement and read off the strike measurement from the edge of the Douglas protractor. So in this case, this looks like 0.19 degrees and dipping 61. I've taken the liberty of measuring the orientations of all of these bedding measurements. So I'll just write them down here. We have our cross-section oriented at 260 degrees with respect to north. That's the orientation of A to A prime, and again measured with the Douglas protractor. So the bedding measurements there are all the bedding measurements, and to calculate the apparent dip, I use the apparent dip calculator online that I posted on the OnQ website under additional resources. I encourage you to practice the calculation so you understand how it works. So I've taken the liberty of calculating the apparent dip of each of the bedding measurements with respect to the cross-section line oriented at 260 degrees. All right, so now we have our information to draw on our diptychs. If we go back up to the cross-section, the first bedding measurement we're looking at, 01961, the apparent dip is 58 degrees, and it's this measurement here, which is our first mark on our cross-section line. The bedding is dipping in that direction toward A prime, so we know on our cross-section it's going to be dipping down from A prime to, in this case, 58 degrees. So we orient our measurement point in the center of the Douglas protractor. We have the Douglas protractor oriented horizontally, and we count down from 0 to 58 as a construction point, and we orient it to the center and draw on our diptych. We have the contacts of the units, and then we have our next measurement here, which is bedding number 2 at 40 degrees, or 46 degrees rather, dipping toward A. The apparent dip is 40 degrees, so we do the same thing. There we go. So as we continue to follow this process through and mark on all of the diptychs across the cross-section line. Sometimes it can be awkward to do the measurement all the way over here, or you may run out of paper, so you can always count up on the opposite side of the Douglas protractor and you'll get the same angle. All right, so there we go. We have all of our diptychs in place. So now we can start extrapolating our contacts from the cross-section line above and below the section. If we have a look at our map starting on the left side, we have our bedding going down and going back up, and we have this syncline. So that's a pretty easy thing to start with. One thing we can should also do is sketch on the cleavage, 79 degrees, to help give us a sense of how we should close our folds to follow the structural style of the map. And again, this cleavage, even though I've only drawn it once here, it would be the same cleavage infinitely all the way along the cross-section line. So I'll draw it in a few places near the fold hinges just for construction purposes. If we follow this bedding measurement to extend down on that side of the hinge, and on this side of the hinge we follow this bedding measurement to extend these contacts just a bit. Here we go. So we've closed one fold. We can lightly color that in. As we go above the section line, our contacts change to dashed lines. And in this case, on this lefternmost or the westernmost part of the map, I'm really just going to follow this bedding measurement to extend the unit off the edge of the cross section. And again, above ground surface, we color things in lighter than below ground surface. And move eastward on our cross section. So we want to start with extending our folds, following these bedding measurements. We have over here the contact with our marker unit and a nearby bedding measurement that we can use to start extrapolating on the other side to work our way to closing the gap between these units. Keeping in mind our structural style of our nice rounded folds, we want to maintain that orientation of the closure as best we can. For these interpretations, you always want to come up with the simplest possible explanation. All right, so let's just check in with our map. Have a look. We've completed our first two fold hinges, and now on the eastern half of the map, it's getting a little bit more complicated. One thing to remember is that everything you see in map view or plan view will project underground. So every single fold hinge has to appear on both the map and the cross section. We have a bit more control on the easternmost fold hinge because we have the plunge of the fold at 34 degrees. We can determine using trigonometry the depth underground at which the marker unit contacts the cross-section line. So if we measure this distance here, I measured it earlier as 8 millimeters on my printout. we can sketch a triangle. If we have 8 millimeters on ground surface, the plunge angle is 34 degrees. Our depth below ground surface, where the fold will intersect the cross-section, is a very simple calculation to solve for h. So we have 5.4 millimeters for h. So we can use a ruler. We have the diptych here from the bedding measurement corresponding to the fold hinge. So we go down vertically from there by 5.4 millimeters. So that point corresponds to this contact between the blue unit C and the marker unit B underground in the cross-section. So our interpretation of the fold in the cross-section is controlled partially by this new piece of data. We can also use the same trig calculation to figure out the depth below ground surface of this fold hinge as well. So if we measure that to be 25 millimeters, we can use the same function where we have 25 times tan 34 to give our h. So our h value becomes 29.8 millimeters. So in our cross section, we're not entirely, we can get a sense of how far along the cross section line we are, and we can transfer the fold hinge from the map onto the section. So the hinge will be down about 30 millimeters. So we can use that to help guide our interpretation. As we continue along, we can actually do the same calculation on the remaining two fold hinges. So we have a very constrained sense of the depth. So we can transfer the hinge locations from the map to the cross-section line again. $11 millimeters, 15 millimeters. If we do the same calculation, we get 7.4. And just over 10. So we can use this to help with our fold interpretation. And as you sketch out and your cross-section and your model is developing in your mind and on paper, you'll end up with quite a few lines to erase and modify as you go. So don't be afraid to revise and improve your geological model on your map and cross-section before you end up with the final model that you're happy with. Okay, so now we have finally reached our last fold hinge, and the last thing to do is run out the fold to the edge of the map, or the edge of the cross-section line, and we can use that last bedding measurement to control our dip. we assume the simplest possible interpretation to finish our section line. So there we go. I'm quite happy with that. So we can go ahead and color in our cross section. When you're coloring above your cross-section line, you really just want to color a reasonable amount to include all of your units. You're welcome to, on a good copy of a cross-section, draw a box outline all the way around it, and you will also need to draw on the scale bar to show that the vertical and horizontal scale are equal on your cross-section. If you put any construction marks or notes on the cross-section line, make sure to erase them if they're not part of the legend. There we go. So we can just say vertical scale equals horizontal scale. And you can put a scale bar on the vertical axes of the cross-section for a formal draft cross-section. So there we go. This is the end of our map demo number 2. Thanks for watching. Bye.